All right, let's just jump right in. Welcome to a very special explainer. Today, we're actually going to turn your screen into a hands-on lab tour. We are looking at something we all use literally every single day, yet we rarely ever see it in action: the invisible forces hiding inside electric wires. We're going to uncover how electricity isn't just about flipping a switch to turn on a light bulb. It's this incredible shape-shifting force that we can literally bend to our will. To really get a sense of the sheer power we're talking about, just take a look at this. We've got this massive industrial crane, and it's just effortlessly hoisting these ridiculously heavy steel pipes in a factory. I mean, it looks like pure mechanical muscle, right? But the secret behind this colossal lifting power, it isn't just gears and pulleys. So here is the million-dollar question we need to investigate. How does a simple, everyday electric wire give a machine the power to lift tons of solid steel? Well, we are going to solve this little mystery together today by conducting some really fun, simple tabletop activities that you could absolutely replicate right at your own desk. Section 1. Electricity's hidden magnetic power. All right, so to find our first clue, we're going to put on our 19th century scientist hats for a second. Imagine you're setting this up on your table right now. Step 1, you stretch a piece of wire right over a regular old magnetic compass. Step 2, you connect the ends of that wire to a standard electric cell and a simple switch. Now watch the compass needle closely. Step 3, you flip that switch to on. And boom, the needle jumps. It instantly deflects away from its original direction. What this proves is absolutely incredible. When an electric current flows through a conductor, like our wire, it actually creates a magnetic field right around it. And the second you turn that switch off, the magnetic field vanishes and the compass needle goes right back to normal. Believe it or not, you just recreated a massive moment in scientific history. Back in 1820, a Danish university professor named Hans Christian Ørsted made this exact same discovery, and reportedly, he did it completely by accident during a demonstration. He realized that electricity and magnetism aren't two separate things at all. They're intimately linked. Moving right along to Section 2, building your own electromagnet. Okay, let's take that weird scientific quirk we just saw and turn it into a practical tool. Check this out. We take some flexible, insulated wire and wrap it super tightly into a coil around a standard iron nail. Connect the ends of that wire to a battery, and suddenly, this totally ordinary piece of hardware has the power to lift metal paper clips right off the table. It looks like a magic trick, but it's pure physics. So what you've essentially built here is an electromagnet, which is, just a technical way of saying it. It's a current-carrying coil that acts like a magnet. But the iron nail? That's the secret ingredient. It acts as a core, and it massively amplifies that invisible magnetic force. Without the iron, the wire coil is kind of just a weak, flimsy magnet. But with it, it's a real tool. Now, this brings up a pretty fascinating question about our new creation. Does our electromagnet have a north and south pole, just like a standard fridge magnet? If you bring that trusty compass back and hold it near the ends of the nail, what do you think is going to happen? The answer is, drumroll please, yes, it behaves exactly like a regular magnet with distinct poles. But here's the absolute best part, the real game changer that makes electromagnets so incredibly useful: we can control it. If you just reverse the battery connections, which changes the direction the current flows, the north and south poles of your electromagnet instantly flip. Section 3, boosting magnetic strength. All right, I want you to put your engineering hats on for a second. We've got a working electromagnet on our desk, sure, but how do we scale this bad boy up to lift a car? Or, those massive steel pipes from earlier? It turns out there are two incredibly straightforward ways to supercharge our magnet's lifting capacity. First, just add more cells to your battery. That pumps up the electric current. Second, simply wrap more turns of wire around your iron core. Both of these simple tweaks dramatically strengthen the magnetic field. And speaking of scaling things up, get ready to have your mind blown. Did you know the Earth itself is essentially a giant electromagnet? Seriously, deep inside our planet, the constant swirling of liquid iron in the core creates these massive electric currents. And those currents generate the Earth's magnetic field, which actually protects us from space radiation. It's the exact same principle as our little battery and nail, just, on a planetary scale. Let's pivot a bit. Section 4, the heating effect. Because magnetism is definitely not the only trick electricity has up its sleeve. Let's set up a new lab station. This time, instead of a coil, we've stretched a very specific type of thin wire. It's called nichrome wire, between two nails on a piece of cardboard. Now, if you let the current run for about 30 seconds, turn it off, and then very carefully touch that wire, you would notice a massive difference right away. That nichrome wire gets remarkably warm, like hot to the touch. And this introduces our next big concept, the heating effect. You see, when an electric current tries to pass through a conductor, it faces pushback, known as resistance. Nichrome has a very high resistance compared to regular copper, so as the current literally fights its way through, all that electrical energy is forcefully converted straight into heat energy.
Now, this may just look like a neat tabletop trick, but it's actually the entire foundation of your morning routine. Any device in your house that gets hot on purpose works on this exact principle. Room heaters, your electric stove, kettles, clothing irons, hair dryers, they all contain a high-resistance heating element inside. They're essentially just scaled-up versions of our little nichrome wire, purposefully generating heat for us to use.
All right, on to our final stop, Section 5, the lemon battery experiment. We're actually moving from the workshop straight into the kitchen for this one. We've been using store-bought batteries to make magnets and heat, but what if we made electricity itself out of groceries? Step 1, grab a standard lemon, stick a copper wire into one side, and an iron nail into the other. Step 2, connect those two distinct metals to a tiny LED bulb using some wires. Step 3, watch in total amazement as the LED actually starts to glow. So what is the science behind this zesty little piece of magic? Well, a cell generates an electric current because of chemical reactions taking place inside of it. In our lemon setup, the copper and the iron act as electrodes, and the super acidic lemon juice acts as the electrolyte. The chemical reactions between those different metals and the juice actually push electrons right through the wire, creating a real current. And the coolest part is, you can totally experiment with this at home. Depending on their chemical makeup, different metals play different roles. Like, if you swap in copper and zinc, the copper naturally becomes your positive electrode, and the zinc acts as your negative one. You can even chain a bunch of lemons together to boost the voltage. So as we wrap up our little at-home lab tour today, let's just summarize what we've uncovered. Electricity is clearly so much more than just some invisible spark hiding behind the drywall. It's a wildly dynamic force that leaves physical clues through incredibly powerful magnetic fields and intense heat that we can easily harness to lift tons of solid steel, warm up our homes, and basically power our entire modern world. We've built deflecting compasses, nail electromagnets, and literally made citrus fruit glow, all using basic physics. Which leaves me with one final provocative question for you to chew on. If you can make a working battery out of a simple lemon, what other hidden scientific secrets are sitting in your refrigerator right now, just waiting to be discovered? Stay curious and definitely keep experimenting.